Do you have devices out on the field and you want to know exactly what's going on with them all the time, even when they crash? Check out Memfault. Memfault is an observability platform that enables embedded engineers to see basically everything that's happening with a connected device. You can see power consumption, the performance, the stability of the code. It'll even give you a big data dump and crash report if anything should go wrong. Best of all, I chatted with Memfault recently and we got a full demo of the platform. I truly hope you enjoy this discussion, and if you want to try out Memfault for yourself, head to ipXchange.tech/sandbox. Hey, it's Amy with ipXchange. We're here at the IPX studios and I'm talking to Gillian from Memfault in another ipXperience. This is going to be one about IoT infrastructure, so it's a little bit different to what we've talked about before, but Memfault are a very interesting company. So without further ado, Gillian, can you just very briefly explain, before we get into the big detail, of what Memfault are all about and what do you do at Memfault?
Yeah, absolutely. Yes, my name's Gillian. I'm an embedded firmware engineer, so I work on device firmware, and most recently I joined Memfault, actually just last year, to work on remote observability. So we're a tool that enables embedded teams to find faults and ship fixes fast. On a day-to-day basis, I work on our device side SDK. I specialize in MCUs, and I also work with customers to enable them to find issues, identify performance differences across their fleet, and then ship firmware updates through our OTA solution.
Nice. So digging a little bit deeper, so can you just explain what Memfault looks like to an engineer and what does it provide to them as a platform?
Yeah.
And we will have a demo of this platform a little bit later in the conversation.
Yeah, absolutely. Yeah, so we kind of have two main categories of our platform. So we've got kind of the observability side. So that's trying to figure out what's going on with your devices that are halfway across the world, in the middle of the ocean, or like in the hands of customers that are running around a city, or, in the middle of nowhere, right? Like in these really strange environments. There's lots of customers we work with in across medical and agri-tech, consumer electronics, right? So you've got these devices in all sorts of conditions. And what we're really looking to enable teams to do is to understand what's going on with them. So from a firmware perspective, from a firmware engineer's point of view, what that looks like is in embedding our device side SDK into their code to capture crashes. So in particular, we wrap the fault handlers on a device so that at the time of a crash, we'll capture a bunch of data before the device resets. We'll save that off to non-volatile memory, and then on boot, we'll have the device upload to our system. And then, say there was a crash in the field and you want to diagnose what's going on with it, instead of, relying on some customer to tell you, oh, like there was a Bluetooth disconnect and then the device reset. That's like not very rich information. That's not going to tell you a lot about what actually happened. Instead, you'll get like a full backtrace of your code at the time of the crash, any global statics, and lots of like really rich information that we can step through later.
Nice. I think you've actually answered a question I was going to ask a little bit later, but I think obviously IoT is a very, very broad category of applications. I mean, you've mentioned medical tech, agricultural technology, but I think one of the main things that people think about with IoT is connectivity protocols. So can you just clarify what connectivity protocols Memfault supports?
Yeah, we pretty much integrate with most protocols. We have a requirement that the minimum transmission unit, so the MTU, is 9 bytes. So as long as that's the MTU, then we can work with your connectivity protocol. So we work with customers, on all the popular platforms or popular connectivity protocols like Wi-Fi, BLE, LTE. But we also have some like maybe more obscure, like less common ones like Iridium, satellite, something that's more bandwidth constrained as well. So we work with a lot of different customers. One of ours has like buoys launched in the middle of the ocean, and so they talk over Iridium and can't upload that much data every day. So we really work closely with folks who have kind of a typical embedded set of constraints, right? Like low bandwidth, low battery usage, those sorts of low memory as well. That's a really big concern of a lot of our customers. So yeah, connectivity is as long as you can talk to the cloud. That's kind of our slogan.
Yeah.
It's like as long as you can talk to the cloud, you can work with us. And yeah, we're very experienced across all of those different protocols. So most recently, I've been working with folks on Wi-Fi. So the ESP32 is kind of a popular platform for us. So
Nice.
it's a popular platform in general, but we have a lot of customers.
Yeah, I did an interview about it earlier on today. It's just so good.
Yeah, and the ESP IDF is like a really robust SDK framework. So there's a lot of tooling there, and yeah, I could go at length on all the details there, but yeah, Wi-Fi is super popular. I think LTE modems are like becoming more and more popular. It's like the cost is going down, and there's more support across different of the generations. 5G, 4G. So yeah, really. Really interesting ecosystem to be working with. It's fun to see everything, all the different combinations of chips and firmware we see it and connectivity protocols we see out there.
Nice. So you briefly mentioned like some of the things that you can do with the platform. Like say if there was an error, you'd get the code back and see where it all went wrong. But in terms of day-to-day operations, what do you see engineers using Memfault for? And then can you just like briefly give a list of some of those key actions that you might have to take if should something go wrong?
Yeah, for sure. Yeah, like I said, and as you touched on, one of the most compelling cases that we see is like an engineer essentially going, oh, like I wonder what's going on with my device. Are there any issues with it? And instead of relying on customer report or it being on your desk, right? Like you get a report remotely, so you can investigate those issues. The other one, that's kind of like that's the part of the platform that collects crashes. That's kind of like call it core dump subsystem. We also have a subsystem for metrics, and that's where you're characterizing the performance of the device. And so we'll report those in a kind of little packet we call a heartbeat. And so it's kind of like a little vital on like how's the device doing, every hour or so, kind of whatever frequency you want to collect data at. We generally suggest about an hour, and so that's what firmware engineers can use, and we can roll up insights to like product managers who want higher level insights. But right, this conversation is mostly focused on firmware, so I'll keep the focus there. Like checking in on the devices that are out in the field, seeing, hey, what's the average performance of my upload to the cloud where I'm sending data, or like the BLE transport. What issues am I seeing there? What kind of performance am I seeing? If there's any disconnects across your connectivity protocol, that's actually one of the categories we like to focus on is connectivity. How is that performing? Capturing like what percentage of the time is your device connected to the internet when it should be, and identifying, okay, there's actually an issue in this firmware release. Let's characterize that using this metric we've captured on the device. So doing that kind of more performance monitoring, that's another piece. And then we have what's like our OTA platform. So what that enables is shipping fixes and shipping updates. So we kind of couple all of these together. We kind of see that in order to do OTA successfully, you also need to understand how the device is performing. And so not only will we allow folks to ship new releases in like a staged manner, say like only 20% of their fleet get like an update. After that happens, taking a look at how are those devices performing? Are they do we actually fix this like connectivity issue we were seeing? And is our battery life like still stable, or is it like plummeting and there's something wrong here? So yeah, getting those insights across that whole like development cycle.
Cool. And just double checking in terms of those OTA updates, that's not something that the end user has to be involved in, is it? Or is it just from the I guess OEM or service provider shipping out the OTA?
Yeah, we're like a OTA provider, so we'll host the payloads and allow you to manage the rollout of that payload. And then it's kind of up to the folks we're working with to decide how how they actually update the device itself. So they can query our system for the payload and drop that into their secondary partition or whatever they want to put that. And then it's up to them on whether they want to like prompt the user. Like I'm thinking, for example, my smartwatch, it'll ask me in my app, like, hey, there's new firmware. Like, do you want to update? That's totally up to them.
Okay, cool. And the other thing is that I think is worth clarifying is um, if uh, if a device goes offline for a while, um, how do you get the reports from the device when it's gone offline?
Yeah, that's a great question. We definitely get that one a lot. Yeah, I mean, obviously, like in order to get any reports from the
Mm,
device, we'll have to have it eventually connect to the internet. But what we do supply is like an API to save off any data that's been collected,
mm,
say to flash. So if you expect there to maybe be an extended period of time that you're disconnected, and there's not enough RAM to hold on to all of the data you've collected over that window, you actually save it off to whatever storage you have. So usually that's
mhm.
some external flash chip, and then when the device comes back online, like grabbing all that data from flash and uploading it to us. So
Nice.
yeah, that's definitely a use case we see. We also see like multi connectivity paths. So maybe
Oh, okay, yeah.
we'll get like
So using
BLE.
backups.
Yeah, exactly. So it's like
Yeah.
there's the common connection is BLE, but maybe if you're not connected to your device and you want to be able to say your architecture is like you want to be able to upload data over LTE in the case of not having your phone nearby the device, then yeah, you can instead like collect the data and shuttle it across that
Okay.
connectivity protocol as well.
Cool. So very, very extensive platform. For engineers just getting started in IoT, what would they have to be doing to get this same functionality if they weren't using Memfault?
Yeah, that's a great question because I think what we tend to see is actually that most devices, most folks we work with actually don't have a ton of insight. They might
Mm,
like push up a couple metrics on how their devices are doing to like maybe the like IoT core and have it push to like a website where they're monitoring devices. But we don't see too robust solutions out there. And
mm,
the other thing that's kind of tricky is in order to kind of have this full solution, you'll require a couple engineers to have some backend knowledge to store data, do SQL queries, and display that information in a way that's usable across the team. And so, right, you need some like front end folks as well. So it requires like a huge team to manage and
mm.
maintain. Really, so when we talk to folks, we kind of try to understand what their priorities are. Is this something that you think you could maintain? And if not, like, we have the whole team that manages this platform and adds updates and adds more features as we go along. And we hear from like so many different hardware companies like what they're struggling with and just build solutions that are right,
Yeah.
like, applicable across all of them. So I think that's actually kind of cool. We it's something I was really excited about when I joined Memfault, is being able to talk
Mm.
to firmware engineers across like totally different domains and totally different
Yeah.
like
As we said, IoT is very vast. So
yeah, gosh. We do have a handful of public customers, but the vast majority are those that we work with privately. And so I can't touch on like all of them, but yeah,
yeah,
we've
of
got a
course,
huge
of course.
array. We've got a huge array of things. You see everything. I have to say, you see everything. So yeah, I do want to mention before I forget though,
Mhm.
is I didn't add this to the intro. So I mentioned I'm an MCU engineer, but we also
Okay.
support Linux and Android as well. So
Mhm. Okay.
yeah, on top of kind of the normal, not normal, but like your typical use cases, I think MCU is pretty like a large portion of the market. We also have support across those two.
Nice. So I guess if I could summarize, you take out a lot of the headache for device monitoring and OTA updates
Yeah.
when compared to trying to do it yourself.
Yeah, and yeah, I think the alternative too is just to kind of expand on the answer a little bit is relying on like other sources of information to like understand what's going on with your system. So that
Mm.
could be right, like customer reports or like they actually have to send back the device. So like learn
Yeah,
notice.
yeah,
Right. So like think that when it comes to really what we're trying to help people with is like not relying on those like much more difficult paths of diagnosing and like understanding performance. So yeah, remote observability is kind of what we say, like monitor remotely. I mean, as a firmware engineer, you're very used to having a device plugged into your desk. That's how you do development. You've got like your JLink, your JTAG debugger, and it's like it's very much what your bread and butter is. And without that, you don't have a lot of insight into what's going on. So we're trying to help people get a clear insight into what's happening when you don't have access to it, when it's out of your hands. It's someone's messing around with it, in a pool and in like really weird RF conditions.
Yeah, and I guess that's going to be horrible trying to get a buoy from the ocean back into the lab for testing.
Oh, yeah. Right, exactly.
Cool.
Exactly.
Oh, and I think it's just worth clarifying if someone's just if someone's already deployed IoT devices, can they still get started using with Memfault? Is it something that kind of comes on top of whatever cloud platform they're using?
Yeah, they can integrate us. Actually, that's I think the most common use cases. We have folks who have devices in the field already, and they're like really wanting to get more insight into what's going on with them. And so you can toss our SDK on top of your existing platform, and then you can either choose to report directly to our cloud, which is the typical use case, or kind of do like a secondary upload. So upload to your own cloud and then transfer to ours. So you can, however your architecture is set up, your cloud infrastructure, we're pretty used to working across different configurations like that.
Cool. And so I'm not super well versed in firmware engineering, but could you put the Memfault SDK into a device via OTA update while it's already out in the field, or does it have to be kind of right at the beginning of the process?
Yes, you can update a device that's like already in the field with Memfault.
Okay.
It would just require integrating the SDK into your build. So you would perform like a full new build of the firmware.
Yeah.
But right, as long as you have an OTA process, and that's something we can help with too. If you're looking for another provider or like additional features, we can work with you on that.
Nice, cool. So I think it's about time we have a look at the platform.
Sweet.
I think so. If you'd like to share your screen or whatever the best way is to do it.
Great. Okay. Yeah. So this is our platform. What I'll do is I'll walk through kind of a debugging investigation where I'm a firmware engineer trying to figure out what's going on with a device that customers have been complaining about having some BLE disconnects and a lower battery life than they expected. We're looking at the Memfault platform for a device called ShapeMate. You can imagine this is like a fitness tracker. It's connected over Bluetooth and it's battery powered. So those are kind of two really important things. Mm-hmm.
And just checking, is there that much difference in the platform for the MCU, Linux, or Android variants, or is it quite similar?
It's quite similar. This is an MCU device.
Yeah.
And it's actually more specifically a Zephyr-based device. So it's MCU-specific data. Like the data we're seeing is MCU-specific, but kind of the flow and like the data we're seeing in general, like these charts and what's being populated, that can be extrapolated across the other platforms like Linux and Android.
Nice. So I'll let you guide me through. And I'll ask questions as they come up.
Perfect. Please definitely jump in. Love questions. I do this demo a lot with customers that are getting started and trying to understand what there is in the platform. And so I love when people are interactive and ask me questions in the middle. We're here in kind of an overview space where we're seeing kind of a general roll up of the fleet and what's going on. So one thing off the bat is the number of active devices we can see right away. So we're at 700. So this is a fairly small fleet, but we've got a lot of devices that are talking to us and giving us some insights. A notable thing here on kind of the status of this fleet is that we recently rolled out a new firmware update to 20% of the fleet, 18%. 1.1.1 was that software version. We were previously on 1.0.0. In this case, we were using kind of this stage rollout feature we have where you can roll out a OTA to only a subset of your fleet. We started getting some reports of issues into the platform, so we stopped it and are trying to see what's going on. We can also get a view of kind of the software versions here on the right. If we take a look at what's going on, at that point in time that the OTA rollout occurred, we are seeing that the trace count went out. So trace count, that's our count of the number of errors. So those could be core dumps or other errors counted. In particular, core dumps, as I mentioned, are the collection of crash information at the time of the crash. So we'll dig into that a little bit more later. But this is telling us that on this date, the 27th, there's an increase in errors being reported into the system. So something happened. It seems to be correlated with that rollout. We can also see the exact issues that happened here as well.
Cool. Just wondering I'm just trying to read it because it's quite small.
Yeah. We'll jump into this one. But essentially, what we're seeing here is there was an assert in the GAP protocol. So listeners might be familiar with the GAP protocol. It's one of the layers of BLE, and so there was something going on in that part of the stack that we'll likely investigate later. But we're seeing that about 107 devices experience this particular issue, and that's increased. You can see the dates also here correlating around that rollout time. Similarly, there's some reboots too. So, correlated with crashes are the kind of reason for reboot, the reboot reason we say. So in particular, we're seeing an increase in this green area, the asserts that are happening. So there's more asserts happening in the system than before. So maybe this was kind of a one-off issue, but actually there's a lot more happening since that point in time. And then hard faults as well. That's we categorize as an unexpected reboot, whereas things like user shutdowns and low power events, those are more expected, right? Like your watch dies or the user turns it off, right? Like those are expected, but these unexpected counts are going up, which is telling us that there's probably something going wrong here.
Okay. So that's just when the system, I guess, crashes and then reboots, is it?
Yeah.
Okay.
Yeah. So kind of at a high level, we're seeing there's something going on at the time that we rolled out this new firmware version. And from here, we kind of want to identify what percentage of the fleet is it, or what amount of the fleet is experiencing this. Is this like a deep issue, or is it maybe a couple devices that are having this issue? What's really the extent of the problem we're seeing? So from here, we're going to go to kind of a fleet-wide view. Call this looking at we call device vitals. So this is insight into some of the most important metrics that we want to use to characterize the performance of our fleet. So one of the things that's important for this device, as I mentioned, is the stability of that BLE connection. And so what we're doing in the firmware right now is capturing what percentage of those syncs to that mobile phone of like your workouts or any other data you want to upload. What percentage of those are successful? And we're seeing that right now in that original version, around 96%. But let's see how that's trending for our new version that we've recently rolled out. So we see that actually has dropped down.
Bad.
Okay, so this is telling us something really important. This is really powerful. It's something we spent a lot of time on last year, the end of last year and early this year, kind of rolling up and adding to the system was seeing, connectivity is a really important part of an IoT device. This is something we should really have highlighted for teams. We want to enable them to build really reliable products, and one of the most important pieces there is that can you even upload data? So we're seeing there's a drop here in that reliability, and then additionally, kind of more higher level, like in general, how stable is the product? And the way we categorize that is what percentage of the hours of operation are crash free. So we were at 100%, which is like really good.
Very good.
Right. Like,
I guess at what point would you say, I guess it is up to the end customer, but what would be kind of an unacceptable level of stability?
Yeah, it's definitely a decision, kind of what's the bar for your team. And so I won't give like a blanket statement on exactly, right? But yeah, we typically encourage folks to identify where they're at, like what's the baseline right now, and at the minimal, like let's not go down from that. But really, just I think like swimming right around that like 97 and up percent If you kind of extrapolate that to the customer experience, right? Like identifying, okay, what percentage of the time I okay with the end customer, like not being able to do what they need to do with the
Yeah.
device, right? So is like 3% okay? Is 2% okay? And the answer is that's gonna depend on the applicability of your device. Like, what's it actually doing?
Yeah.
So if maybe it's a fitness tracker, that doesn't matter as much. But maybe if it's like a medical device that,
I was
like,
just about to say you don't want unreliable medical devices.
right,
Yeah.
yes. So this is really key, and it is like, I wouldn't say simple is not the right word, but it is kind of a nice snapshot. Like, okay, wow, how stable is the product? Right? It's kind of a very simple statement. So we like to highlight this to not just firmware folks, but kind of the folks that are at a little bit higher level, like product managers. Like, hey, how stable is the device? This will tell me, do I need to invest more resources here, or are we in like a good state?
Cool. So I guess actually I do want to go back quickly because I think I saw on the device stats battery life, but we didn't actually scroll down to it.
Yeah, I can jump over actually. So we have a roll up in the overview, but I'll show you quickly what
Yeah.
this is actually the third vital that we have. So I'm glad you you brought it up. I can show you quickly, kind of a similar comparison that we were just seeing.
Oh, okay. So it really does give you in hours, and
Yeah. So this is probably one of my favorite parts of like the call it metric subsystem, like the data we're capturing. So we'll actually we'll integrate with your fuel gauge and capture the percent drop of the battery for each hour, and then we'll use that value collected across a few hours and be able to extrapolate to the expected battery life. So we'll do that for, as long as we have your a connection to your fuel gauge and we can identify what the state of charge is, we'll give you this estimate. So this is again a pretty important metric for a lot of devices. I don't know about you, but I definitely am very cognizant of like my smartwatch's battery. It's like a pretty big deal. So I know that that's a big deal for a lot of customers too. And so this is something to be definitely paying attention to.
And just clarifying on those graphs, is what is the spread? Is that just the spread of total battery life across that whole update? And is the darkened line the mean, or what are we seeing?
Yeah, so what we're seeing here is a breakdown of the percentiles.
Okay.
So we're seeing across the down from the first percentile all the way to the 90th percentile. What's the performance? So what we're seeing here is that for the lowest performing devices, we're getting a battery life of about like 22 hours, which is pretty poor. So while our median here is not so different across the firmware version, these two firmware versions, we're seeing a pretty significant regression.
Okay, I see.
Some of the devices. So I think what this is telling us is there's something going on with a particular subset, and we're gonna have to take a look at what's going on with those ones in particular. I would definitely love to go into this if we have time, but I want to jump back to
I think we can probably do a more detailed one of these later, but a good overview would be the best way to start.
I will mention that like if we look into battery life a little bit more, I'll go into this for the BLE, but we can go from here to the devices that are experiencing that. So this is like a drill down, and as you might like notice from the name here, like these are devices that are experiencing particularly poor battery life, and so there's something, just as a hint, like there's something that's unique about those ones that we can track and help with diagnosing the issue.
Cool.
So I'll actually go back to where we were. I'm actually going to save this view. So when I save it, I can actually save this, grab this URL, and I send it to my team and say, hey, I'm looking at this regression. There's something going on here, and directly indicate to them this comparison that I'm concerned about and really want to zone in on.
Cool.
So I hinted at the drill down feature, so we can drill down into like what's going on with those devices that have that 77% BLE sync success rate. So you can see we're filtering one of our filter views, filtering on those devices. And so I'm going to jump into, say, this top one and see what's going on there.
I guess, and this is an individual device.
Yes, exactly. So this is a device. This is its serial number. We've got some information on, its like software version, like when's the last time we saw it, things like that to identify, what the context of this device is. And then as we scroll down, we see what we call like the timeline view. So this is telling us all the data that's been collected on this device displayed over time. And what I've done here right before this is filtering by a few key metrics. These are telling us some important information about the performance of the device. So we were looking at BLE syncs, and we saw that there was an issue that was rolled up on that overview page related to the GAP protocol. So I definitely want to look at the sync failures. So I'm thinking that's probably what's going on here is some sort of BLE issue. So I went ahead and highlighted the sync failures. We can see that it spikes, and then that's correlated with actually some reboots, and we're seeing actually a trace record coming through. And then I also wanted to highlight here how this might be affecting the battery. So this gray line is the state of charge % drop, and we're seeing that spike right around these sync failures. So you can imagine, we're we're trying to upload data, and we're trying a bunch of times, and that's a very high power event, trying to send data across our connectivity protocol. And so our battery life drops a lot in that particular window.
Cool. Well, there is a lot of information there.
I know it's a pretty rich view. I won't go into everything.
Of course not.
A lot more like things to dive in here. But another thing I want to highlight, just to kind of contextualize what's going on with the device. At a high level, you're kind of like, okay, this is a fitness tracker. Like, there's probably going to be some workout sessions going on, and something that we've enabled folks to capture is what kind of windows of time are occurring for the device that are unique to that device operation. And in particular, for this one, it's a fitness tracker, so there's workouts being recorded, and so we can see what was actually happening contextually with the device. Not only what data is being captured, but like how was the customer using this device. So we can see,
I guess you could So if it say like every time someone went out on a run, it crashed, then you'd know that there's something wrong with what's going on at that time.
Yeah, and you'd know that they're probably not having a great experience in the middle of their run, like they're losing their data. They're probably upset about that. So if you can see that ahead of time, you'd be able to drill down into what's going on before they start reporting issues and maybe throw their device in like their closet and never use it again, right?
Yeah.
But yeah, I think what you can kind of extrapolate here is that there was a running session, and then right after that we tried to upload data, right? So they went for a run and then tried to sync their data to their phone. I did this morning, right? Like I went for a run and then tried to upload my data, and I could see it in my app. But if something went wrong like this, I want people to see that. So it's an important part of the user experience. This is where things start to get a little more exciting, is going, okay, we see a bunch of metric data. There's some issue going on. There's some sync failures. And what exactly is going on with the device? So we captured some crash information. And what I'll do is I'll jump into this particular crash. And so this is kind of the view that drew me in when I first learned about the product as a firmware engineer, because you get to see really like the state of the system. So I'll kind of adjust my view here. But on the left here, we see all of the threads that are running in the system. We've got a main thread, idle, UART thread for our shell, and then the syswork queue for Zephyr. This tells us that the main thread was running and the state of the other ones were ready and blocked. So it gives us a context on, okay, so this was the one that was running at the time of the crash. I can trace this back to, there was this function that was running in QNext packet, and something went wrong there. It was an assert that was captured. I could take a look at any of the registers and locals that were captured in that particular trace. in that particular frame, and investigate what's going on there. We also capture lots of different pieces of memory that you might be interested in, so all sorts of globals and statics, and then you can view them in this memory viewer on the right. I've got some familiarity with this like memory viewer view in VS Code and other tools, and so it's nice to be able to see that here too. A lot of engineers are familiar with like their local setup, and that's what they use on a day-to-day basis. What do you use when this is an issue that's happening, right? Like in a different country. So this is a very familiar view for a lot of firmware engineers.
Good.
It's like, okay, yeah, this feels like I have GDB set up and like my debugger is connected.
Cool. I guess we could just like keep on diving and diving and diving, but probably a good thing to see on the platform without going into full detail is how do you go about solving these issues?
Absolutely.
And I guess sending a new OTA update.
Yeah, definitely. This one. I'll just briefly mention that for this particular issue, we had some people dive into it and say, hey, there was an allocation failure actually, and we need to adjust the way that we're handling asserts, and they're going to try to ship it in a new version. And so the next step here is to go, okay, we ship a new version. Let's see that that's actually doing what it's supposed to be doing. Are we actually fixing the problem? And so we can characterize that with this same metric.
Nice. Okay.
Compare across that version. And yeah, we see this sync success rate go up, which is great. And then we see our stability score go up as well.
Good.
Yeah. So that's kind of characterizing. I think this is pretty powerful to go, okay, as a firmware engineer going, okay, I spent like a day investigating this issue and diving into the debug view and taking a look at what's going on. Did it actually solve things for the system? And this kind of gives you that answer, which is pretty cool. I will mention that for the battery life issue, we'll see that there was an improvement, but that it's not quite as good as we hoped.
Yeah.
So there's a little bit more going on there. Since we don't have too much time today, I won't dive into that, but folks can jump on our demo instance and maybe investigate for themselves and try to figure out what happened here.
Nice. And that is actually a perfect segue into what I was going to ask next is if someone's enjoyed this conversation and wants to have a play with it themselves, what's the best way to get started with Memfault?
Yeah, so the first thing I would encourage is checking out our sandbox demo. So it looks just like this, but you can log in and we've got a little core dump. It's like core dumpling's like our little mascot that'll navigate you around the application and get familiar with it. You can dive into issues yourself. So that'll give you a chance to see like on your own how you navigate with the system and explore data. And the next thing from there is, talking to us about the issues you're experiencing. We've got a bunch of firmware developers on the team who very much relate to the issues that you might be running into, or maybe there's not all gloom and doom, right? There's also like a new feature you're shipping and you're like super excited about it, and you really want to know if users are taking advantage or if it's performing as you expected. That's something we can enable too. So we love to hear from people. Reach out to our team and we can have a conversation.
Excellent. And this is always a question that we love to ask people. But if someone were to approach you, who would your ideal customer be?
Yeah, it's a good question. I would say that we really like working with folks who have a lot of devices in the field and are trying to identify like trends. That's typically like a really good use case for us. Consumer electronics, that's a common one. So I would say that's kind of the standard. And we do work with a lot of different people, so I don't want to exclude anybody. And silo any particular demographic of company or product. But yeah, I would say like the typical use cases: consumer electronics, big fleet, maybe growing, trying to find issues in the field and don't have a lot of insight into what's going on. One of the customers that I'm talking to right now is they've been working on a product that's been really successful the past 4 years. They're shipping a new device later this year, and they realize like, wow, we're growing at a rate we can't really sustain, and need like some more tools, some more mature tools to figure out how to build a more reliable device. And on top of that, they've got some really cool, high profile customers that they want to really deliver a reliable product for. And so that's important to them too, is like monitoring those devices and going, hey, what's going on with those ones? And so there's a lot of different use cases, but I would say that's generally where we love to jump in. The best time to integrate Memfault is like when you first design a device, because you can start to observe it throughout the lifetime. But generally speaking, we like to jump in as well when you've got a mature product and you're looking to build a more reliable product moving forward into like a growth phase.
Nice. Well, I think that's a really, really good intro to Memfault with a practical demo, which we always love. So thank you so much, Gillian, for joining us today and showing us the Memfault platform and explaining how it all works. And I guess the best thing to do would be, I'll say to anyone watching, if you want to get started with Memfault, check out the sandbox demo. But we'll have quite a bit more content coming on Memfault soon, explaining some more use cases and how this observability platform works. So yes, thank you again, Gillian. And I'm really excited to speak to your team more about this exciting platform.
Yeah, looking forward to it.
Where my engineers at?